STIMI. A destination for learners. Today we're going to learn the first lesson of chemistry. Some basic concepts of chemistry. Welcome to today's lesson. We're going to be learning about importance of chemistry, nature of matter, properties of matter and their measurement, uncertainty in measurement, laws of chemical combinations, Dalton's atomic theory, atomic and molecular masses, mole concept and molar masses, stoichiometry and stoichiometric calculations. Let's start with some definitions. Atomic mass unit. An atom mass unit is defined as a mass exactly equal to 1/12 of the mass of a carbon atom minus 12. 1 AMU equals 1.66056 times 10 power minus 24 G. The AMU has been changed to the U, called the unified mass. Atomic mass. The average relative mass of an atom of an element concerning the mass of a carbon atom minus 12 taken as 12. Molecular mass. The molecular mass of a substance is defined as the average relative mass of its molecule concerning the mass of a C minus 12 atom taken as 12. It expresses how frequently the molecule of a substance is heavier than 1/12 of a carbon atom mass. Formula mass. Summation of the atomic masses of the elements present in one formula unit of a compound. It is used for ionic compounds. Molar mass. The mass of 1 mole of a substance in grams is called its molar mass. Molar volume. It is the volume occupied by 1 mole of any substance. Vm denotes it. The unit of molar volume is liter per mole or milliliter per mole. Empirical formula. It is a formula representing the simplest whole number ratio of the various atoms present in a compound. For example, CH is the empirical formula of benzene. Molecular formula is a formula that shows the exact number of different types of atoms present in a given molecular compound. For example, C6H6 is the molecular formula of benzene. Importance of chemistry. A. In agriculture and food. It has provided chemical fertilizers such as urea, calcium phosphate, sodium nitrate, ammonium phosphate, etc. It has helped to protect the crops from insects and harmful bacteria, by the use of certain effective insecticides, fungicides, and pesticides. The use of preservatives has helped to preserve food products like jam, butter, squashes, etc. for longer periods. In health and sanitation. It has provided mankind with a large number of life-saving drugs. Today, dysentery and pneumonia are curable due to discovery of sulfa drugs and penicillin life-saving drugs. Cisplatin and Taxol have been found to be very effective for cancer therapy, and AZT, azithromycin, is used for AIDS victims. Disinfectants such as phenol are used to kill the microorganisms present in drains, toilet, floors, etc. A low concentration of chlorine, i.e., 0.2 to 0.4 parts per million, ppm, is used for sterilization of water to make it fit for drinking purposes. Saving the environment. The rapid industrialization all over the world has resulted in lot of pollution. Poisonous gases and chemicals are being constantly released in the atmosphere. They are polluting environment at an alarming rate. Scientists are working day and night to develop substitutes which may cause lower pollution. For example, CNG, compressed natural gas, a substitute of petrol, is very effective in checking pollution caused by automobiles. Application in industry. Chemistry has played an important role in developing many industrially manufactured fertilizers, alkalis, acids, salts, dyes, polymers, drugs, soaps, detergents, metal alloys, and other inorganic and organic chemicals including new materials contribute in a big way to the national economy. Nature of matter. Anything which has mass and occupies space is called matter. For example, book, pencil, water, air are composed of matter as we know that they have mass and they occupy space. They are classified into two. Matter can exist in three physical states. 1. Solids. 2. Liquids. 3. Gases. 1. Solids. The particles are held very close to each other in an orderly fashion and there is not much freedom of movement. Characteristics of solids. Solids have definite volume and definite shape. 2. Liquids. In liquids, the particles are close to each other but can move around. Characteristics of liquids. Liquids have definite volume but not definite shape. 3. Gases. In gases, the particles are far apart as compared to those present in solid or liquid states. Their movement is easy and fast. Characteristics of gases. Gases have neither definite volume nor definite shape. They completely occupy the container in which they are placed. B. Chemical classification. Based upon the composition, matter can be divided into two main types. 1. Pure substances. 2. Mixtures. 1. Pure substances. A pure substance may be defined as a single substance, or matter, which cannot be separated by simple physical methods. Pure substances can be further classified as I. Elements, 2. Compounds. Mixtures. The combination of two or more elements or compounds which are not chemically combined together and may also be present in any proportion, is called mixture. A few examples of mixtures are milk, seawater, petrol, lime water, paint glass, cement, wood, etc. Types of mixtures. Mixtures are of two types. I. Homogeneous mixtures. A mixture is said to be homogeneous if it has a uniform composition throughout and there are no visible boundaries of separation between the constituents. For example, a mixture of sugar solution in water has the same sugar-water composition throughout and all portions have the same sweetness. 2. Heterogeneous mixtures. A mixture is said to be heterogeneous if it does not have uniform composition throughout and has visible boundaries of separation between the various constituents. The different constituents of a heterogeneous mixture can be seen even with naked eye. For example, when iron filings and sulfur powder are mixed together, the mixture formed is heterogeneous. It has grayish-yellow appearance and the two constituents, iron and sulfur, can be easily identified with naked eye. Differences between compounds and mixtures. Compounds. 1. In a compound, two or more elements are combined chemically. 2. In a compound, the elements are present in the fixed ratio by mass. This ratio cannot change. 3. Compounds are always homogeneous, i.e., they have the same composition throughout. 4. In a compound, constituents cannot be separated by physical methods. 5. In a compound, the constituents lose their identities, i.e., a compound does not show the characteristics of the constituting elements. Mixtures. 1. In a mixture, or more elements or compounds are simply mixed and not combined chemically. 2. In a mixture the constituents are not present in fixed ratio. It can vary. 3. Mixtures may be either homogeneous or heterogeneous in nature. 4. Constituents of mixtures can be separated by physical methods. 5. In a mixture, the constituents do not lose their identities, i.e., a mixture shows the characteristics of all the constituents. We have discussed the physical and chemical classification of matter. A flow sheet representation of the same is given below. Properties of matter and their measurements. Physical properties, those properties which can be measured or observed without changing the identity or the composition of the substance. Some examples of physical properties are color, odor, melting point, boiling point, etc. Chemical properties, it requires a chemical change to occur. The examples of chemical properties are characteristic reactions of different substances. These include acidity, basicity, combustibility, etc. Units of measurement. Fundamental units, the quantities mass, length, and time are called fundamental quantities and their units are known as fundamental units. There are 7 basic units of measurement for the quantities: length, mass, time, temperature, amount of substance, electric current and luminous intensity. SI system. This system of measurement is the most common system employed throughout the world. It has given units of all the 7 basic quantities listed above. Definitions of basic SI units. 1. Meter. It is the length of the path traveled by light in vacuum during a time interval of 1/299792458 of a second. 2. Kilogram. It is the unit of mass. It is equal to the mass of the international prototype of the kilogram. 3. Second. It is the duration of 919-2631-770 periods of radiation which correspond to the transition between the 2 hyperfine levels of the ground state of cesium-133 atom. 4. Kelvin. It is the unit of thermodynamic temperature and is equal to 1/273.16 of the thermodynamic temperature of the triple point of water. 5. Ampere. The ampere is that constant current which, if maintained in 2 straight parallel conductors of infinite length, of negligible circular cross-section and placed 1 meter apart in vacuum, would produce between these conductors a force equal to 2 × 10⁷ N per meter of length. 6. Candela. It may be defined as the luminous intensity in a given direction, from a source which emits monochromatic radiation of frequency 540 × 1012 Hz and that has a radiant intensity in that direction of 1/683 watt per steradian. 7. Mole. It is the amount of substance which contains as many elementary entities as there are atoms in 0.012 kg of carbon-12. Its symbol is mole. Mass and weight. Mass. Mass of a substance is the amount of matter present in it. The mass of a substance is constant. The mass of a substance can be determined accurately in the laboratory by using an analytical balance. SI unit of mass is kilogram. Weight. It is the force exerted by gravity on an object. Weight of substance may vary from one place to another due to change in gravity. Volume. Volume means the space occupied by matter. It has the units of length, 3. In SI units, volume is expressed in meter 3, m3. However, a popular unit of measuring volume, particularly in liquids, is liter, L, but it is not in SI units or an SI unit. Mathematically, 1 L equals 1000 ml equals 1000 cubic centimeters equals 1 dm3. Volume of liquids can be measured by different devices like burette, pipette, cylinder, measuring flask, etc. All of them have been calibrated. Temperature. There are 3 scales in which temperature can be measured. These are known as Celsius scale, degree C, Fahrenheit scale, degree F, and Kelvin scale, K. Thermometers with Celsius scale are calibrated from 0 degrees Celsius to 100 degrees Celsius. Thermometers with Fahrenheit scale are calibrated from 32 degrees Fahrenheit to 212 degrees Fahrenheit. Kelvin scale of temperature is SI scale and is very common these days. Temperature on this scale is shown by the sign K. The temperature on 2 scales are related to each other by the relationship density. Density of a substance is its amount of mass per unit volume. So, SI unit of density can be obtained as follows. This unit is quite large and a chemist often expresses density in gcm3 where mass is expressed in gram and volume is expressed in cm3. Uncertainty in measurements. All scientific measurements involve certain degree of error or uncertainty. The errors which arise depend upon two factors. I. Skill and accuracy of the worker. 2. Limitations of measuring instruments. Scientific notation. It is an exponential notation in which any number can be represented in the form n(x)(10n), where n is an exponent having positive or negative values and n can vary between 1 to 10. Thus, 232.508 can be written as 2.32508x102 in scientific notation. Now let us see how calculations are carried out with numbers expressed in scientific notation. I. Calculation involving multiplication and division. 2. Calculation involving addition and subtraction. For these two operations, the first numbers are written in such a way that they have the same exponent. After that, the coefficients are added or subtracted as the case may be. For example, significant figures. Significant figures are meaningful digits which are known with certainty. There are certain rules for determining the number of significant figures. These are stated below. 1. All non-zero digits are significant. For example, in 285 centimeters, there are 3 significant figures, and in 0.25 ml, there are 2 significant figures. 2. Zeros preceding to first non-zero digit are not significant. Such zeros indicates the position of decimal point. For example, 0.03 has 1 significant figure and 0.0052 has 2 significant figures. 3. Zeros between 2 non-zero digits are significant. Thus, 2.005 has 4 significant figures. 4. Zeros at the end or right of a number are significant provided they are on the right side of the decimal point. For example, 0.200g has 3 significant figures. 5. Counting numbers of objects. For example, 2 balls or 20 eggs have infinite significant figures, as these are exact numbers and can be represented by writing infinite number of zeros after placing a decimal. i.e., 2 equals 2.0000000, or 20 equals 20.0000000. Addition and subtraction of significant figures. In addition or subtraction of the numbers having different precisions, the final result should be reported to the same number of decimal places as in the term having the least number of decimal places. For example, let us carry out the addition of 3 numbers 3.52, 2.3, and 6.24, having different precisions or different number of decimal places. The final result has 2 decimal places, but the answer has to be reported only up to 1 decimal place, i.e., the answer would be 12.0. Subtraction of numbers can be done in the same way as the addition. The final result has 4 decimal places, but it has to be reported only up to 2 decimal places, i.e., the answer would be 11.36. Multiplication and division of significant figures. In the multiplication or division, the final result should be reported up to the same number of significant figures as present in the least precise number. Multiplication of numbers. 2.2120x 0.011 equals 0.024332. According to the rule, the final result equals 0.024. Division of numbers. 4.2211 divided by 3.76 equals 1.12263. The correct answer equals 1.12. Dimensional analysis. Often while calculating, there is a need to convert units from one system to other. The method used to accomplish this is called factor label method or unit factor method or dimensional analysis. Laws of chemical combinations. The combination of elements to form compounds is governed by the following 5 basic laws. 1. Law of conservation of mass. 2. Law of definite proportions. 3. Law of multiple proportions. 4. Law of gaseous volume. Gay-Lussac's law. 5. Avogadro's law. Law of conservation of mass. The law was established by a French chemist, A. Lavoisier. The law states: in all physical and chemical changes, the total mass of the reactants is equal to that of the products. In other words, matter can neither be created nor destroyed. The following experiments illustrate the truth of this law. A. When matter undergoes a physical change. Ice congeals to water by heating. It is found that there is no change in weight though a physical change has taken place. B. When matter undergoes a chemical change. For example, decomposition of mercuric oxide. During the above decomposition reaction, matter is neither gained nor lost. Law of definite proportions. According to this law, a pure chemical compound always consists of the same elements combined together in a fixed proportion by weight. For example, carbon dioxide may be formed in a number of ways, i.e., by burning coke in air, by decomposition of limestone on heating, by the action of diluted HCl on washing soda. Gay-Lussac's law of gaseous volumes. The law states that, under similar conditions of temperature and pressure, whenever gases combine, they do so in volumes which bear simple whole number ratio with each other and also with the gaseous products. The law may be illustrated by the following examples. A. Combination between hydrogen and chlorine. B. Combination between nitrogen and hydrogen. The two gases lead to the formation of ammonia gas under suitable conditions. The chemical equation is Avogadro's law. Avogadro proposed that equal volumes of gases at the same temperature and pressure should contain equal number of molecules. For example, if we consider the reaction of hydrogen and oxygen to produce water, we see that 2 volumes of hydrogen combine with 1 volume of oxygen to give 2 volumes of water without leaving any unreacted oxygen. Dalton's atomic theory. In 1808, Dalton published a new system of chemical philosophy in which he proposed the following. 1. Matter consists of indivisible atoms. 2. All the atoms of a given element have identical properties including identical mass. Atoms of different elements differ in mass. 3. Compounds are formed when atoms of different elements combine in a fixed ratio. 4. Chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. Atomic mass. The atomic mass of an element is the number of times an atom of that element is heavier than an atom of carbon taken as 12. It may be noted that the atomic masses as obtained above are the relative atomic masses and not the actual masses of the atoms. One atomic mass unit, AMU, is equal to L/12th of the mass of an atom of carbon-12 isotope. It is also known as unified mass. Average atomic mass. Most of the elements exist as isotopes which are different atoms of the same element with different mass numbers and the same atomic number. Therefore, the atomic mass of an element must be its average atomic mass, and it may be defined as the average relative mass of an atom of an element as compared to the mass of carbon atoms, C12, taken as 12W. Molecular mass. Molecular mass is the sum of atomic masses of the elements present in a molecule. It is obtained by multiplying the atomic mass of each element by number of its atoms and adding them together. For example, molecular mass of methane, CH4, equals 12.011 U plus 4, 1.008 U. Equals 16.043 U. Formula mass. Ionic compounds such as NaCl, NO3, Na2C03 etc. do not consist of molecules, i.e., single entities, but exist as ions closely packed together in a three-dimensional space. In such cases, the formula is used to calculate the formula mass instead of molecular mass. Thus, formula mass of NaCl equals atomic mass of sodium plus atomic mass of chlorine equals 23.0 U plus 35.5 U equals 58.5 U. Mole concept. It is found that 1 gram atom of any element contains the same number of atoms and 1 gram molecule of any substance contains the same number of molecules. This number has been experimentally determined and found to be equal to 6.022137 x 1023. The value is generally called Avogadro's number or Avogadro's constant. It is usually represented by Na. Avogadro's number, Na equals 6.022 into 10 power 23, percentage composition. One can check the purity of a given sample by analyzing this data. Let us understand by taking the example of water, H20. Since water contains hydrogen and oxygen, the percentage composition of both these elements can be calculated as follows. Empirical formula. The formula of the compound which gives the simplest whole number ratio of the atoms of various elements present in one molecule of the compound. For example, the formula of hydrogen peroxide is H2O2. In order to express its empirical formula, we have to take out a common factor 2. The simplest whole number ratio of the atoms is 1:1 and the empirical formula is HO. Similarly, the formula of glucose is C6H12O6. In order to get the simplest whole number of the atoms, common factor equals 6. The ratio is equals 1, 2, 1. The empirical formula of glucose equals CH20. Molecular formula. The formula of a compound which gives the actual ratio of the atoms of various elements present in one molecule of the compound. For example, molecular formula of hydrogen peroxide equals H2O2 and glucose equals C6H12O6. Molecular formula equals NX empirical formula, where N is the common factor and also called multiplying factor. The value of N may be 1, 2, 3, 4, 5, 6 etc. In case N is 1, molecular formula of a compound equals empirical formula of the compound. Stoichiometry and stoichiometric calculations. The word stoichiometry is derived from two Greek words stoichion, meaning element, and metron, meaning measure. Stoichiometry, thus deals with the calculation of masses, sometimes volume also, of the reactants and the products involved in a chemical reaction. Let us consider the combustion of methane. A balanced equation for this reaction is as given below. Limiting reactant/reagent. Sometimes, in alchemical equation, the reactants present are not the amount as required according to the balanced equation. The amount of products formed then depends upon the reactant which has reacted completely. This reactant which reacts completely in the reaction is called the limiting reactant or limiting reagent. The reactant which is not consumed completely in the reaction is called excess reactant. Reactions in solutions. When the reactions are carried out in solutions, the amount of substance present in its given volume can be expressed in any of the following ways. 1. Mass percent or weight percent, W/W percent. 2. Mole fraction. 3. Molarity. 4. Molality. Mass percent, it is obtained by using the following relation. Mole fraction, it is the ratio of number of moles of a particular component to the total number of moles of the solution. For a solution containing N2 moles of the solute dissolved in N1 moles of the solvent. Molarity, it is defined as the number of moles of solute in 1 liter of the solution. Molality, it is defined as the number of moles of solute present in 1 kilogram of solvent. It is denoted by m. Lesson summary. All substances contain matter which can exist in 3 states: solid, liquid or gas. Matter can also be classified into elements, compounds, and mixtures. Element, an element contains particles of only one type which may be atoms or molecules. Compounds are formed when atoms of 2 or more elements combine in a fixed ratio to each other. Mixtures, many of the substances present around us are mixtures. Scientific notation, the measurement of quantities in chemistry are spread over a wide RHNGE of 1031 to 1023. Hence, a convenient system of expressing the number in scientific notation is used. Scientific figures, the uncertainty is taken care of by specifying the number of significant figures in which the observations are reported. Dimensional analysis, it helps to express the measured quantities in different systems of units. Thanks for your attention. Do subscribe for more lessons. And thanks for watching. Leave your suggestions below in the form in description.